5 Mysteries of the Solar System. We've all wondered at some point or another, what mysteries our solar system holds. After all, the 8 planets, plus Pluto and all those other dwarf planets, orbit within a very small volume of the heliosphere. What's going on in the rest of the volume we call our home? As we push more robots into space, improve our observational capabilities and begin to experience space for ourselves, we learn more and more about the nature of where we come from and how the planets have evolved. But even with our advancing knowledge, we would be naive to think we have all the answers. So much still needs to be uncovered. What are the greatest mysteries within our solar system? So, get the ball rolling. Number 5. Why is the solar atmosphere hotter than the solar surface? Now this is a question that has foxed solar physicists for over half a century. Early spectroscopic observations of the solar corona revealed something perplexing. The Sun's atmosphere is hotter than the photosphere. In fact, it is so hot that it is comparable to the temperatures found in the core of the Sun. But how can this happen? If you switch on a light bulb, the air surrounding the glass bulb won't be hotter than the glass itself. As you get closer to a heat source, it gets warmer, not cooler. But this is exactly what the Sun is doing. The solar photosphere has a temperature of around 6,000 Kelvin, whereas the plasma only a few thousand kilometers above the photosphere is over 1 million Kelvin. As you can tell, all kinds of physics laws appear to be violated. However, solar physicists are gradually closing in on what may be causing this mysterious coronal heating. As observational techniques improve and theoretical models become more sophisticated, the solar atmosphere can be studied more in depth than ever before. It is now believed that the coronal heating mechanism may be a combination of magnetic effects in the solar atmosphere. There are 2 prime candidates for corona heating: nanoflares and wave heating. I for one have always been a huge advocate of wave heating theories, but there is strong evidence that nanoflares influence coronal heating too, possibly working in tandem with wave heating. Although we are pretty certain that wave heating and/or nanoflares may be responsible, until we can insert a probe deep into the solar corona, which is currently being planned with the Solar Probe mission, taking in situ measurements of the coronal environment, we won't know for sure what heats the corona. Number 4. What caused the Tunguska impact? Forget Fox Mulder tripping through the Russian forests. This isn't an X-Files episode. In 1908, the solar system threw something at us. But we don't know what. This has been an enduring mystery ever since eyewitnesses described a bright flash that could be seen hundreds of miles away, over the Podkamennaya Tunguska River in Russia. On investigation, a huge area had been decimated, some 80 million trees had been felled like matchsticks and over 2,000 square kilometers had been flattened. But there was no crater. What had fallen from the sky? This mystery is still an open case, although researchers are pinning their bets of some form of airburst when a comet or meteorite entered the atmosphere, exploding above the ground. A recent cosmic forensic study retraced the steps of a possible asteroid fragment in the hope of finding its origin and perhaps even finding the parent asteroid. They have their suspects, but the intriguing thing is, there is next to no meteorite evidence around the impact site. So far, there doesn't appear to be much explanation for that, but I don't think Mulder and Scully need be involved. Number 3. Why are the Pioneer probes drifting off course? Now this is a perplexing issue for astrophysicists, and probably the most difficult question to answer in solar system observations. Pioneer 10 and 11 were launched back in 1972 and 1973 to explore the outer reaches of the solar system. Along their way, NASA scientists noticed that both probes were experiencing something rather strange. They were experiencing an unexpected sunward acceleration, pushing them off course. Although this deviation wasn't huge by astronomical standards, 386,000 kilometers off course after 10 billion kilometers of travel, it was a deviation all the same, and astrophysicists are at a loss to explain what is going on. One main theory suspects that non-uniform infrared radiation around the probe's bodywork may be emitting photons preferentially on one side, giving a small push toward the Sun. Other theories are a little more exotic. Perhaps Einstein's general relativity needs to be modified for long treks into deep space. Or perhaps dark matter has a part to play, having a slowing effect on the Pioneer spacecraft. So far, only 30% of the deviation can be pinned on the non-uniform heat distribution theory, and scientists are at a loss to find an obvious answer. Number 2. How do we know the Oort cloud even exists? As far as solar system mysteries go, the Pioneer anomaly is a tough act to follow, but the Oort cloud is one of the biggest mystery. Why? We have never seen it. It is a hypothetical region of space. At least with the Kuiper belt, we can observe the large KBOs and we know where it is, but the Oort cloud is too far away, if it really is out there. Firstly, the Oort cloud is predicted to be over 50,000 astronomical units from the Sun. That's nearly a light year away, making it about 25% of the way toward our nearest stellar neighbor, Proxima Centauri. The Oort cloud is therefore a very long way away. The outer reaches of the Oort cloud is pretty much the edge of the solar system, and at this distance, the billions of Oort cloud objects are very loosely gravitationally bound to the Sun. They can therefore be dramatically influenced by the passage of other nearby stars. It is thought that Oort cloud disruption can lead to icy bodies falling inward periodically, creating long-period comets, such as Halley's Comet. Number 1. The mystery of dark matter. No one knows much about this particle, except to be pretty sure it's something we've never encountered here on Earth. It doesn't interact with light, hence the name dark matter, which means that it's neutral, with no electrical charge. It's also slow-moving, being concentrated in galaxies and clusters rather than dispersed evenly throughout space. Even though we don't know what it is and we can't see it, we do know that dark matter matters.